Welcome. My name is Okubo Benebo. Scoping the farm produce of subsistence farm is a necessary task that must be performed for the end results of healthful living. Clearly, the scoping enables the farmer to discover deficiencies in the earlier selection of crops and accordingly expand the scope, which in this case currently consists of the essential crops plus the added foods of soy, quinoa, and fish. The healthfulness functionality of the new additions, soy, quinoa, and fish actually duplicate each other, but have all been included in taking the lifestyle of vegans into consideration. Because there is already plants in the essential crops, fish would have been preferable, but vegans also have to be helpful. The vegan's lifestyle prefers eating plant than flesh of any kind, and hence the need for the additional crops when the fish does the same. And so the plant's food scope got expanded despite the inclusion of the fish. So then, in pattern maintenance of the farming activities prevailing, the sowing of the added plant foods seeds, the cultivating of the functionality duplicate plant, and invariably the related harvesting continue the farming activities of the subsistence farming. Significantly, the scoping undertaking resulting in the inclusion of the additional 3 food items results in the human body being availed with all the proteins it needs to function healthfully and without suffering the stresses of even one node of the metabolic reaction network utilizing amino acids being vacant, with the concomitant reactions inefficiencies from imbalance of the pool between node of one type of proteins the body is manufacturing versus a node hole having dormant enzymes as the network reaction progress. Noteworthy, the amino acids acquired from the 3 added foods are admittedly biological amino acids being produced within a biological context. Yet of consideration is whether or not it is equally feasible to provide the missing proteins by means of chemical synthesis as per the GGS amino acids process shown at the end of the episode, given the fundamental difference between biological synthesized chemicals and chemically synthesized chemicals. In a naivety understanding, the difference can be attributed to the phenomenon of biocondensation, which accompanies biological reactions as solution chemicals get converted into biologically active substances. Biocondensation, by and large, is essentially operating at the quantum magnetic level, at which matter is essentially condensed in terms of its energy state to a lower state without release of its internal energy content. Invariably then, it is better to have the biologically synthesized amino acid than the chemically synthesized amino acid, unless as substitution for use in the lack thereof of the biologically synthesized amino acid, which by happenstance are available in large quantities through the added foods. In synopsis then, this episode entitled Farming Essential Foods, Soy, offers a structured presentation of the planting of the myriad versions of soy under a common didactic guidance, so both the novice and the expert benefit from the knowledge. Proffers alternative approaches to the handling of the dual impact factors of pest attacks and microorganism infections of soy. Special treatment of biofertilizers as to dynamically uplift the fruitfulness of the soil and consequently the productivity of the soy plant. And ultimately, the evolving of the soy farming process for implementation in the farming process automation controller system. The driver rationale guiding farming the essential food, soy, has the object of evolving a unified planting approach suitable for planting all variants of soybeans such that every subsistence farmer of soybean need know only one method. A starting point of this unification of the planting scheme, of course, is the fixing of the planting specifications such that the same specification also apply to all variants of the soybean. Now then, soybean is planted over a widespread condition of temperature so long as the temperature is higher than 50 degrees Fahrenheit and no hotter than 70 degrees Fahrenheit. So then, the planting condition could be fixed at between 50 and 65 degrees Fahrenheit at the lower end, with 55 being the preferred target minimum for planting. By similar reasoning then, the highest temperature to be tolerated in the farm would be put at between 60 degrees Fahrenheit and 70 degrees Fahrenheit, with the optimum being 65 degrees Fahrenheit. By the way, it is also known that the plant tends to simply grow and not ready to bloom so long as the sunlight is not very bright and also shines for a shorter span than relative to the day-night hours split. Then, of course, the longer it takes to bloom, the more bountiful the harvest. So then, the planting scheme must also consist of a singular planting approach that carefully graduates the intensity of the light irradiated on the plant to be such as to induce maximum yield of bean pods. Also known in the science, of course, is that the exposure of one form of biologic into another results in a modification of the added biologic, no matter how slight. So then it means the contents of amino acids in these beans can be significantly increased by enriching the biofertilizers with carboxylic acid that the cells transform biologically into amino acid, and rather readily consequent on the short-circuiting of the metabolic reactions by the anabolic reaction that otherwise would have had the task of producing the carboxylic acids. Now then, by these driver rationale then, a unified planting approach development can be easily abstracted, yet the planting would still start with the seeds. Further, the planting of the soybeans is being done on one ridge or single row, and with the seeds to be planted 2 to 3 inches apart and about 1.5 to 2 inches deep. As always, the planting activities start with preparing the ridge for the planting. Comparatively, the biofertilizers used for the planting of soy is somewhat different from the versions used in the prior planting operations. The fact that soy is aggressively attacked by various fungi and microbes meant equally aggressive steps also must be taken to address and stem the attacks. Of course, it is well documented at this time that biological zinc does inhibit the festering of fungi and microbes in biologic systems. So the quality of the biofertilizers get improved significantly with the addition of large quantities of pineapple skin puree, which has high zinc contents and correspondingly provides unmatched protection to the plants from microbial infections. Now then, at about 4 inches from one end of the ridge, a 4-inch diameter by 1 foot deep hole is scooped out. Optionally, sunken bed containers are then emplaced or embedded and then refilled with zinc-enhanced biofertilizers. This is replicated through the span of the ridge with 5-inch spacing between centers. The biofertilizers filled holes are then watered wet and then left overnight. At about 24 hours later on the following morning, coming on now to the onset of the planting, with the biofertilizers appearing to be reasonably dry, a spherical hole of diameter 3 inches is scooped out, and one soy seed being placed in the middle of the apparent bowl, and then covered first with scoop of pure pineapple puree, followed with the biofertilizers scooped out. This covering with the biofertilizers serves two purposes. First, it provides a cover for the seed and seedling through germination. Two, it forms a film-like coating cover on top of the soil, which prevents extreme evaporation of water, yet lets watering diffuse down. The use of the puree, being in keeping with the object of the zinc antimicrobial properties, actually protects the plant through its life cycle. The sowed seeds are lightly watered regularly until the seeds grow out of the soil above the surface, above the ground surface. The light dispersers network branch for irradiation of the plants is mostly fitted with attenuators and so calibrated such that the irradiation is of lower intensity in order to permit full growth. Further, to the extent possible, the sides of the farm space cage are mildly shielded to give relatively darker space than the outside, and the plant then grows in an improvised, dimly lit, controlled, light variant space. Preventing the usual pests from impacting the plants is also an aspect of the unified planting approach. A stemming of the pest's impact on the growth of the plant is just as important. An approach to this issue is somewhat more scientific than would be relatable to the traditional subsistence farmer. Even so, governments in the locality of the farms may be able to provide advisory professionals to aid. Now then, generally, proteins, including those of the pests, are in the natural quaternary configuration, the geometric microstructure, by a recessional electron, the cloud of which envelopes the protein. Magnetic studies have suggested that disrupting the electron, whether by affecting the angle of spin known as the recessional angle or the circulation wave part around the protein known as the polarization, disrupts the configurational structure of the protein, resulting ultimately in the deconstruction of the quaternary configuration. Then, of course, such deconstruction is the onset of asphyxiation of the cell and invariably the organism bearing the protein. Obviously, then, the pest control dynamic can be implemented with a mechanism that disrupts the recessional angle of the electrons of the proteins of the pest. A suitable mechanism dynamically creates and destroys planar polarity switching magnetic field such that the field is always above the plant height and of no thickness more than the length of the largest of the pests. Further, the polarity switching of the field creates pseudo-alternating magnetic field akin to the dynamics of the magnetic field of an EM wave. But most importantly, the dynamics is tuned to disrupt, no matter how slight, the recessional angle of the recessional electron of target proteins of the pest. Indeed, the flux of pseudo-alternating magnetic field, each tuned to disrupt a protein in a target pest, is deemed implementable and is implemented. In effect, a pest floating about in the air above the plants is subjected to the pest-specific pseudo-EM magnetic field that disrupts the recessional angle, and so the pest keep away on feeling some discomfort upon entering the magnetic field zone. Under these conditions, the plants are guaranteed to grow to a height of 36 inches, but the higher yield plants could grow up to 72 inches in height, and that is desired. The growth to 72 inches is induced with a slight change of the biofertilizers, somewhat about the 4-inch diameter scooped out at the start of the planting process. Carboxylic acids and amino acids are placed over the surface and then slightly watered to cause a diffusion into the soil all about the roots of the plant. Really, the origin of the substance does not matter here, whether the source is chemically synthesized amino acids, because in context, the plant has a base substance on which to merely effect the biocondensation that brings about the biologically synthesized amino acid contents of the cell. This gives the plant sturdiness to grow higher. Finally, the control task sequence of the light intensity tuning, the root space watering program, the carboxylic and amino acid feed process, as well as the usual farming tasks such as weeding and spacing, are integrated into a coherent soil farming process and then included in the farm process automation control system discussed in episode 10 by characteristics as template. Finally, after the plants reach about 60 inches in height or higher, the shading of the light about the cage is removed and the irradiation of the light disperser is turned on full intensity, so the plants begin to prepare to bloom and grow buds that are saturated with amino acids drawn up from the roots when so fertilized. The conclusion that could be drawn here is that scoping deemed to be important is still recommended, simply because the choice of inclusion of both soy and quinoa is redundant and the farmer has the option of just choosing one. Then, of course, that choice, even if inclusive of both soy and quinoa, does not preclude fish. All three added foods are valid to be chosen with careful consideration. In a sense, the presentation of the farming activities of soy here is not absolute. A farmer still does not have to choose soy to satisfy that complete amino acids demand, or even start off with the essential crops relative to which the scoping has been performed. Indeed, the unified planting scheme for soy has been abstracted as related here and could be adopted for subsistence farming that ensures bountiful yield, but even more significantly, produce yields that are of unusually high contents of amino acids. Just as instructively, the growth of soy plants can be supported without the use of chemical pesticides, but rather with the use of biologic zinc to fortify the resistance to infection of the plants by microbes, and as a result, limit the exposure of humans to synthetic chemical substances, the reactions mechanism scope of which likely exceeds that of the corresponding biological substance. Agreed, the implementation of the pest control mechanism is not readily accessible to the average subsistence farmer, yet the concept is viable and effective for consideration by every farmer suffering pest impact issues on any particular farm produce. And it is a wrap. On that note, I say to you, thank you so much for having come to listen to this observation about efforts aimed at alleviating world hunger through subsistence farming by both urban dweller farmers and emergent countries' small farm farmers. You are truly appreciated, and if you would like to get privileged viewer, reader information, access podcasts of specialized contents, or even access vertically integrated concepts, then I implore you to join my supporter club and enjoy that privileged status. Moreover, while still here, do please take a moment and subscribe to the channel as to be informed of the publication of every new episode as soon as it is released. Thank you. Bye. Till next episode.